In this video, I want to give you a little bit more context on the workspace view of AdaCAD. So some of the terms we use to describe what's happening in the workspace may be more or less familiar to different people. So AdaCAD works by using a style of design called parametric design. And in parametric design, you create a data flow of little draft builders. So instead of starting from a whole draft and filling it in with structures, what you're doing is creating small drafts and growing them into something bigger. So one of the best ways to understand what a data flow is or what parametric design is by looking at one of the operations in AdaCAD. So when you're in the workspace view, you'll see that there's a whole panel of operators. Each operator either generates a draft that follows specific rules or modifies that draft in some ways. So it's often usually drafts are going to be started with structures. So what we have here are a series of structure generators. And what these structures generators do is they don't just create one structure, they create derivatives that also obey the rules of that structure. So behind the scenes in AdaCAD, each one of these on-screen operators, like we're seeing here, is linking to computer code that is writing which heddles are raised and lowered according to which rules. So what you'll see in Twill, as most weavers know, I'll get rid of this tabby, is that when you have a twill or a twill structure, a generic rule can apply to all different kinds of twills. And that rule, in AdaCAD anyway, and what I've seen in some books, is that you start with the first pick, and whatever the pattern is on the first pick, you repeat on the second pick. But when you repeat it, you also shift it by one. So it essentially takes your first pick's pattern and almost draws it diagonally. In AdaCAD, we basically just use computer code and math to generate twills based on those rules. So these first two numbers here define that first row. So this first number tells us how many warps are raised in the first row, or the first pick. Then it tells us how many warps are lowered in the first pick. We can use this toggle here to change the direction of the twill from an S twill to a Z twill. And we can use this last selector to change whether or not we want it to be warp facing or weft facing. So you'll see with this one function, we can generate all kinds of twills. And that's fine, and it's actually quite enjoyable from the perspective of programming to try to figure out the math between all of these. But where this ability to change the parameters is really valuable is when you're not just creating one structure, but you're also modifying and generating those structures parametrically. So I'm going to tell you a little bit more about that. Here we start with a twill, and let's go ahead and change, add another kind of operation that's not a structure generator, but it's a transform function. So my favorite is actually this make symmetric. So if I add this transformation operator, what it wants me to do is it has something I call an inlet. It wants to take in a draft, and it's going to modify the draft in some way that I specify using these two select lists. So to give it a draft as input, I select the output of a draft that I'm interested in connecting. So in this case, the twill, and I connect it to the input of the make symmetric operation. Now you can see that it's taken this twill and it's rotated it around the top left corner. I might want to change that to the top right corner. I might want to change that to the bottom right corner. So I can change that. I can take away the center repeat. I can keep the center repeat in. So what becomes really interesting here is now that if I change the parameters up here, the relationship still holds all the way down what I call the data flow. So the data flow here is a twill connected into a make symmetric. So let's add more to our data flow. Let's try tile. And what's also kind of nice is we can create branching data flows. So maybe I want to see what it looks like if I tile it. So repeat that pattern a number of times across the width and the length. Or I can use the rectangle to say, just keep repeating that pattern for, let's say, 60 ends and 25 picks. So what we see here is you don't just have to have one data flow. You can branch it and actually create multiple different kinds of drafts or compared drafts. All right, and then again, if I change the values up here, we see how they change all the way down the line. So I hope that's given you a little bit of insight into parametric data flows. One final note that I'd like to make before we end this video is you can create drafts that you draw by hand into these data flows. So let's say I want to add my own draft, and I'm going to make it 5 by 5. Okay? It adds a blank draft to this data flow. What actually I'm going to do is I'm going to zoom in on that blank draft, and I'm going to start editing it. So let me just make a draft that's not a very well-known pattern. So it's this zigzag looking thing. I can take this draft and give it as an input to an operation by connecting the outlet on the draft to the inlet of a different operation. So, what we see here is that currently the twill goes into make symmetric and then is tiled and put into a rectangle. If I want to change that to my own draft, I go ahead and just hit the X on the connection connecting the twill and make symmetric, and then I add in my hand-drawn draft. And now you can see that it's tiled that draft instead, and it's made it symmetric. What's nice here is I can also come in and just change that draft a little bit and see what happens. All right, well, I hope you enjoyed this video, and I hope it helped demystify just a little bit what we mean by parametric design and parameter and operation and data flow.